Hello and welcome to this video on factors that influence rate of reaction. So there are four main factors. We're going to focus on the AQA GCSE again. This could be a good refresher for A-level in fact. So factor number one is surface area. So I want you to imagine a cube with four faces on each large face. If we call each of these faces 1, then if we count the number of faces across the whole cube, that's 24. Now, if I break this into the 8 cubes that it's made up of, each again with a face of 1, then my surface area becomes 48. Now, this shows how surface area can change as we crush something up and make it smaller. What it also shows is that we have all this extra surface available for a reaction. We have all that extra surface for a successful collision between reacting particles. So, as we increase surface area, which I'm just going to call for the purpose of notes SA, as we increase surface area, we increase rate. The rate gets faster with a greater surface area because there's more reacting surface. Factor number 2 that influences a rate of reaction is concentration. So, if we imagine a box with two particles, A and B. And if I imagine a box, again, the same size, or near as makes no difference in my drawing, with two A's and two B's. This kind of represents my high concentration, HC. This obviously my low concentration. In this scenario, high concentration, I'm much more likely to have a collision. All of these rates can be explained with the frequency of successful collisions. So these particles, obviously if there's more of them in the same space, are more likely to have a collision and a reaction. So with higher concentration, higher rate. So I'll just put high conc equals high rate. And it's the same effect with pressure as well. We're compressing these particles into a smaller space. We're increasing the effective concentration. Obviously, if this is a gas phase reaction, increasing the effective concentration with pressure, and meaning that we're more likely to get successful collisions. So that's concentration. We've looked at surface area. Now it's time to look at the third effect, which is temperature. Now, if I imagine again this box with A and B, if these particles are moving slowly, then they're not as likely to hit. Think about it running around in a room. If you're just walking around a room with another person, you're not as likely to run into them. If two people are moving very quickly, there's a chance you're going to collide. Now also with temperature, more particles are likely to have a successful collision. Not all collisions are successful, and at higher temperature, the particle's going to have more energy. There's more chance of them overcoming that activation energy. So we can say definitely that temperature, or I should say high temp, equals high rate. the higher my temperature, the faster my rate of reaction. The faster the particles move, more likely to have successful collisions. The fourth way to increase a rate of reaction is a catalyst. With a catalyst, if we look at an energy level diagram, which in AQA you saw in the previous module, we put reaction progress along the bottom, or reaction coordinate. A catalyst provides an alternative pathway of a lower activation energy. So in the normal route here, we have our activation energy up to the top of this peak. That's the activation energy of the normal pathway. But if I had a catalyst, I lower my activation energy to the top of this peak. And if I lower my activation energy, then more molecules are likely to have a successful collision. They need to collide with less energy than they did before to overcome that barrier and form the products. So a catalyst is the fourth and final way to increase the rate of reaction. Because we're lowering that activation energy, more likely to have successful collisions. So that's 4 factors that influence rate. Hope you enjoyed it. We'll see you in the next one.